Hello, everyone. I am Qi Xiaoxiao, a master's student from Central China Normal University, Wuhan, China. The title of my presentation today is Multi-Programming Language Commits in Open Source Software, an empirical study on Apache projects. Firstly, I will expound the motivation of this work. With the technology advances, multi-programming language software development is increasingly prevalent. Reusing existing code and taking advantages of specific programming languages are main reasons. Despite great benefits of multi-programming language systems, they are also facing various challenges. For example, static code analysis is much more difficult in multi-programming language systems than mono-language systems. Although there are a few studies that investigated the quality of multi-programming language systems, these studies took a project or pull request as an analysis unit, which is at a relatively high level and may not provide specific advice for software development practices. In contrast, a commit is in a finer granularity than a project or pull request, and developers deal with code changes in commits in daily development practices. We explored the multi-programming language commits, MPLCs for short, in 20 non-trivial Apache projects with over 200,000 commits. For research question 1, what is the proportion of MPLCs over all commits of a project? We extracted commit records from 20 repositories and found that the percentage of MPLCs is 9% when taking all projects as a whole. We further investigated the trend of the proportion of MPLCs in each selected project over time. As shown in the right diagram, we can see, after relatively strong fluctuations in the early development stage of the project, the proportion of MPLCs of most of the projects tend to be stable in the late development stage. Research question 2 is about how many programming languages are used in the modified source files of MPLCs. We explored how the number of programming languages used distributes over MPLCs, and the result is most MPLCs involve source files written in only 2 programming languages. And it is not common for MPLCs to modify source files in more than 4 programming languages. Research question 3 is about what is the code change complexity of MPLCs. Is there a difference on the code change complexity between MPLCs and non-MPLCs? Change complexity can be measured by the number of lines of code modified, number of source files modified, number of directories modified, and entropy of source files modified. We further ran Mann-Whitney U-tests on the 4 measures of MPLCs and non-MPLCs for each project. The results show that the change complexity of MPLCs is significantly higher than that of non-MPLCs in every selected project. Research question 4 is, do the issues fixed in MPLCs tend to take longer to be resolved than issues fixed in non-MPLCs? We associated each commit with the specific issue. The conclusion is that 16 out of 20 projects have longer open time of issues fixed in MPLCs than that of issues fixed in non-MPLCs, and the other 4 projects do not show a significant difference. The average open time of issue fixed in MPLCs is 8% to 125% longer than that of issues fixed in non-MPLCs for the 16 projects. Research question 5 is about are source files that have been modified in MPLCs more bug-prone than source files that have never been modified in MPLCs. Bug proneness of a source file can be measured by defect density of the file. We found in 80% of the selected projects, the source files that have been modified in MPLCs are more bug-prone in terms of defect density than source files that have never been modified in MPLCs. And the difference between them ranges from 70% to 3,682%. There are some implications for practitioners and researchers. Our future research will focus on the following direction. Firstly, investigate how MPLCs and software architecture interplay in multi-programming language software systems. Then, use MPLCs as an additional factor to enhance bug prediction models for multi-programming language systems based on existing models. Thank you for your attention. Questions now.
Hi. So
Hi.
Xiao is here. So anybody has a question, please feel free to put it in the chat. Okay, maybe I can start with first question. Oh, okay. Felipe asks, would you expect any impact of those commits for reviewers in the code review process as well?
Oh, okay. I think our research results show that there is a significant difference between multi-programming language commit and non-multi-programming language commit. And in the selected project, multi-programming language commit have an impact on the software quality. So I think we can give some suggestions to practitioners and researchers. And for practitioners, we can suggest them avoid using multi-programming language commit as much as possible. And they can pay attention to the files which written by which modified by multi-programming language commit. And for researchers, they can consider the interaction between multi-programming language commit and software architecture. So the four reviewers, we also refer it much, and I think this empirical study is meaningful.
Okay, thank you. I'm wondering, what are the popular programming languages that you found to go together?
What can you repeat it?
Because there are multiple languages, right? Oh, I think we reached the